Hello, my name's Mark E. Wilson, Dr. E. from La Cañada High School, and today we're going to be covering the first two units, first two sections of Unit 9, Global Change. 9.1 is Stratospheric Ozone Depletion, 9.2 is Reducing Ozone Depletion. For 9.1, the main learning objective to explain the importance of stratospheric ozone to life on Earth. It's important because without it we wouldn't have had evolution. Stratospheric depletion is caused by anthropogenic factors, and a decrease in stratospheric ozone increases the UV rays that hit the Earth, which can lead to such things as increase of cataracts or skin cancer, which has been exemplified in Australia. And the suggested skills is to be able to describe the environmental concepts and processes involved with this. So stratospheric ozone and life on Earth. Ozone in the stratosphere absorbs UVC, UVB, lets UVA through, fortunately, because UVA is what allows us to make vitamin D. Without the ozone layer, life on land would not be possible, since UVB and UVC radiations causes tissue damage and mutates DNA. 600 million years ago, photosynthesis really started playing. When it did, oxygen went up into the atmosphere, not just into the troposphere, but up into the stratosphere. And we'll see what happens in a few minutes because of that oxygen. But without that, life would not be possible. Human health benefits of stratospheric ozone, including prevention of skin cancer and cataracts. UVB and UVC mutates DNA and oxidize and cause stress on the eyes. One of the ways that it causes cancer, is it damages the DNA, but it also causes the immune cells to leave the area. Therefore, every time you get a sunburn, you double your chances of getting skin cancer. Remember, the tropospheric ozone, where we are, causes respiratory irritation, damaging to plant tissue, and it's a precursor to photochemical smog. Just think about it. O2 is able to oxidize iron. O3 is much, much more reactive. And so the stratosphere is right through here, and that is what causes the damage. The good stuff up here. So how does ozone absorb UVB and C? Well, UVC breaks oxygen into two free oxygen atoms. Okay? When the free oxygens from this atom, they can combine with O2, forming O3. So one of these O's can combine with an O2, giving us O3. Or it could go back and combine with another O. UVC reverses the reaction by breaking ozone into O3 and O, which can then bond with another O and form O2. But the continued formation and breaking of ozone in the stratosphere absorbs the UVC and UVB radiation, protecting the organisms on the Earth. Remember from physics, then when radiation is absorbed, it is re-emitted at a lower frequency. Well, that lower frequency is blue, the part of the blue light that we see. And what we have done, the man-made ozone depletion, CFCs, chlorofluorocarbons, are a primary human cause of ozone breakdown. It was first discovered and made and used in making refrigerators and air conditioners and aerosols, such as hairspray and Febreze and stuff like that. We now use something else, fortunately. UV radiation causes the free carbons in here, the free chlorines, to separate from the CFC. So UV radiation hits the CFCs, chlorine breaks off. The highly electronegative chlorine atom binds to one of the oxygens of the ozone, converting it to O2. The free oxygen atoms then binds with the ozone, the oxygen from the chlorine monoxide to form O2, and a free chlorine atom to break down more. And so this breaks apart, breaks the ozone apart, and it's able to do this over and over again. One single chlorine atom persists in the atmosphere for 50 to 100 years, can destroy up to 100,000 ozone molecules. So the natural depletion, it happens every year down in the Antarctic and the polar region. The Antarctica spring melt forms polar stratospheric clouds. The clouds are made of water and nitric acid. They can only form in minus 100 degree Fahrenheit temperature range found above Antarctica. In the presence of PSCs, the chlorine nitrate and hydrochloric acid react and give off chlorine. This chlorine is catalyzed by the sun into 2 free chlorine. And that you remember from last slide what the chlorines are able to do. They break down the O3 to O2 over and over and over again. And that's why you can see here that there's an ozone hole. The ozone hole has been there for millions of years. And it grows and shrinks during different times of the year. For 9.2, reducing ozone depletion, we're going to be, the learning objective to describe chemicals used to substitute for CFCs. So, many ways to reduce ozone depletion is by phasing out and replacing CFCs. There was a Montreal Protocol in 1987, which was a global agreement to phase out CFCs out of production in refrigerator, aerosols, and other use. They stopped being made in 1987, right about that time. Now, remember, that chlorine can stay up there for long periods of time. It was replaced by HCFCs, the CFCs with a hydrogen instead of the chlorine. These can deplete the ozone and act as greenhouse gases, but to a lesser degree. Now, when they are, as the lesser degree is to destroy ozone, they are 2,000 plus times as good of a greenhouse gas as CO2. So CFCs have a huge ozone depletion and a high global warming potential. GWP is global warming potential. HCFCs have a low ozone depletion but a high global warming potential. HFCs have a 0 ODP but a high, and HFOs, which we're trying to go to, have 0 ozone depletion, but a very low greenhouse. It's not a permanent solution, the HCFCs, but a temporary transition option. We want to phase out in developing countries after 2020, developing nations after 2030. Replacements for HCFCs is HFCs, but it's still a greenhouse gas, but doesn't deplete the ozone. The replacement for HFCs are HFOs. Okay. They're HFCs with carbon-carbon double bonds with shorter atmospheric lifetime and greenhouse gas potential. So the practice FRQ is for 9.1 and 9.2. Again, describe potential responses or approaches to environmental problems. So 1, can you describe how stratospheric ozone protects organisms on Earth from UV radiation? Can you describe how CFCs deplete stratospheric ozone? Can you explain how the Montreal Protocol decreased ozone depletion? Thank you, and I hope that was helpful.